All right, we are ready to go. So what we're going to do today is we are going to finish up our look at Chapter 4, those key ingredients for inferential statistics. We looked at probability. We've now incorporated the normal curve. We've incorporated the unit normal curve table at the back of the book. So today we're just going to kind of wrap that up and introduce a little bit of the next step, the next idea that we're going to encounter. So one of the things that you want to do, because in statistics, everything builds upon everything. So unlike other courses where you might learn about a certain area of psychology and then you go on to a different area, so you really don't have to, master the areas before. In statistics, you need to be able to do exam number one. You need to have those skills in order to move on. So if you at all did not get 100% on exam number one, make sure that you know why. Make sure that you could get 100% now. And if you still are confused, make sure that you do what you need to do in order to get those skills. Because as we move forward, we're going to be using z-scores, we're going to be using standard deviations, we're going to be using frequency distributions, and you need to have those really rock solid in your arsenal in order to proceed. So what I want you to do is use this information from exam number one as exactly that. Use it as information to kind of gauge where you're at. So I put up the scores for exam number one in a frequency distribution here so we can kind of see what's going on. So first off, congratulations to those students right there. You guys are doing exactly what you need to do. Keep at it. Everything is great. If this is you, I think we got one. If that's you, probably a little slip of the wrist, probably just a little error somewhere. Hopefully today you saw exactly where it was that you lost your points, and hopefully you were saying to yourself, "Oh, I can't believe I did that. I know better." If you don't, figure it out. If you can't, come see me. Right? Do not let it go. But probably just a little slip of the wrist. If I had to guess, probably the sum of 2 times the score is -1. I think that would probably be the one right there. All right. If you're here in these 2 bars, either you kind of had a few mental errors, you had a few sort of slip of the fingers, maybe you didn't use the equals function as often as you should have. Whatever it is, it's either that or you might have missed an entire question. That's typically where students end up in that area. If you missed an entire question, if it was a little mental error, a little slip up, try to tighten up those skills. If you missed an entire question, again, make sure you know what needs to be done. Don't just go forward without understanding how it is that you needed to do that. So for example, if you could not calculate the standardized scores for the z-score questions, make sure that you do not let yourself go forward without figuring out how do I calculate those standardized scores. And then finally, if this is you down here, a couple of things to keep in mind. Number one, don't panic. This is very typical of the progress of some students in statistics, okay? So not everybody is on board right off the bat, but everybody will get on board. So one of the reasons why I love having these frequency distributions up is that every single class that I've ever taught, as the exams go on and on and on, all of these bars start moving over here. And you can visually see like every single student getting into the 80s, the 90s, and the 100s. So if this is you, number one, don't panic. That is why your worst exam is worth so little towards your final grade. So if this is your worst exam, use it as the information that it gives you. It's not going to detrimentally impact your GPA. It's not going to impact your grade in this course. So that's part one. That's the good news. The other news, though, is something needs to change. All right. So if you're here, something about the way that you're doing the course needs to change. So whether it's doing more of the practice, whether it's doing more of the study plan, whether it's maybe watching the YouTube videos for a second go through, if it's coming to me for my office hours, whatever it is that you need to move up, make sure that you do it, because this is just an indication that if nothing changes, then nothing's going to change. And we don't want to stay here. We want to make sure that everybody is moving up. All right, so that was exam number 1. Any questions about that before we move on? All right, so today we're going to wrap up our look at inferential statistics, wrap up our look at the normal curve. And once again, we are getting so close. We got a couple of more steps before we get to the point where we can start taking a look at actual experiments. We're going to visit some key experiments from the history of psychology to see what these psychologists actually did. So the stats that we're going to be doing when we do inferential statistics are exactly the same statistical tests that these classic psychology experiments were based on. So we're so close to doing the super cool stuff. We just need a few last pieces. We need a few last components before we're ready to be unleashed. And once again, I'll be using this example over and over again. This is why we're in here. This is why we're learning inferential statistics. So keep that goal in mind, because as we go further, this is right around this area is sometimes where the stumbling blocks occur for certain students. So right around this area is the point where it's either going to make sense immediately for you, or it's going to make sense on the second time you see it, or it's going to make sense on the 4th time you see it, or it's going to make sense maybe on the 7th, 8th time you see it. It will eventually sink in, but it might not be automatic. So think about why we're doing this when the difficulties come. We are opening up psychology for everybody. Remember that all the experiments in psychology, those hundreds of thousands of millions of experiments that psychologists do, that learn about psychology, open up psychology, without statistics, anything that you learn, like a new teaching technique to help autistic children, would be limited to the sample that you learned it on. And you could not intelligently generalize. And again, I'll remind you, intelligently generalize. If you go through the history of science, you will see time and time again, people unintelligently generalizing. And not to find a point on this, racism and sexism is the human mind unintelligently generalizing, right? You see one instance and you say, well, that's the way they all are, right? That's what our minds are very susceptible to do. We don't want to do that for psychology. What statistics is we offload that to a procedure that's objective, so our own biases don't enter into anything. And what this is going to do is it's going to generalize intelligently from the sample to the population, so we can help every single person in the population. We can look at a sample and then help every single autistic child in the world, and that's why we're here, that's why it's required. So if you're doing your homework and you're struggling, if you're reading your chapter and it's just not making sense, picture it in your mind. Picture these 12 autistic children, and then picture the world that we can help with inferential statistics. All right, so once again, normal curve, this is where we're at right now. Just a real quick recap. The normal curve is what happens when multiple independent factors combine to give you a single score. So that happens so often in psychology, that happens so often in human behavior and human cognition, that the normal curve is a very useful curve, especially for psychologists. So what we're going to do today is we are going to have a real quick recap of how to do z-scores and the normal curve table. And then we're going to have a little time for in-class practice. And then once we're done that, we're going to take a very brief kind of intro to samples and populations, because we are now coming up to the point where that difference is going to become really important. We're coming up to the point where dealing with the sample and dealing with the population are going to be two very different things, and we need to start thinking about that. We're going to introduce the idea of the distribution of sample means, and then we'll talk about the central limit theorem. All right, so last time when we met, we took a look at how to use the unit normal curve table, Appendix 1, and how to answer questions where you start with a raw score and you're asked for a percentage. So those are the 5 steps that we looked at. So if you're starting with a raw score, hey, you scored 333 on your SATs, and you want a percentage, what percentile rank are you? These are the steps that you would use to get that answer. And as we saw last time, the percentile you are in is 4.75, and that means that 4.75 of the population scored as well or lower than you, and about 95% scored better than you. Incidentally, this might be a good time to mention, when you're doing your homework, when you're doing your exam, if it's asking you for something and you're not entirely sure what it is, feel free to Google it, especially in an exam. So if I ever ask you, oh, what's the percentile rank? And you're sitting there going, I can't remember, percentile rank is people above me or people below me? Which one is percentile rank? You're like 20 seconds away from just checking that out. And honestly, that was one of the ones that for me, when I was learning this, I could never remember. Is it everybody above you? Is it everybody below you? So just take a look at that if you need it. If you start with a percentage, on the other hand, that's the other thing you can do. You start with a percentage. You want to be in the top 1%. What score do you need? We're looking for a raw score. In that case, we have these 5 steps here. And we went through that last time and saw that if you want to be in the top 1%, you need a z-score of 2.3. You need to be 2 1/3 standard deviations above the mean in order to get into that top 1%. So that's what we did. Oh yeah, and then you convert that into the raw score. So for SAT scores, you need a score of 733 if you want to be into that top percent. So what we're going to do now, I know you've already had a little bit of practice on this with your homework. We're going to do a little bit more right now in class. So we have an Excel sheet that I prepared for week 6, class 2 practice. So that is chapter 4. So the one that you're looking for is this one right here. So what we're going to do now is we're going to have, let's go for about, let's do about 15 minutes on this. So there's 2 questions here. And what you want to do is really kind of make sure that you know how to use that table. So what we're looking for here is for each of these z-scores, you want to put into these answer cells what percentage is below that z-score. So what percentage of the normal curve is below the z-score? What percentage of the normal curve is between the mean and your z-score? And what percentage is above the z-score? And those are the 3 areas that you are most interested in. That's going to cover about 99% of all these situations. So we have a few of those to do. And then example number 4 here, we have cases where you are given a percentage and they're looking for a raw score. So it gives you the distribution of salaries for nurses in the US, and it asks you what salary do you need, what raw score do you need to be in the top 15% of salaries, and then what percentile rank, what percentage are you given the raw score of 30,000, and then another one with IQ scores. So once again, starting with a raw score, given 144, what percentage are you? And then given a percentage in the top 9.18%, what IQ do you need to make it to that level? So we'll have about 15 minutes for everybody to give this a shot. Call me over if, give it a shot, on your own, and then call me over if you have any questions, and we'll just make sure that everybody's got these basics down by the end of the day. So I forgot to put this one in there. So this is going to be one for that I did want to cover for everyone. So the question was, for question number 3, how do you find the area between two z-scores? So a lot of times when you're doing work in psychology, you want to find things that are between 2 scores, right? So a lot of things in psychology don't work for extremes. but only work for people within a certain range. So what we need to do in those cases is, let's go over here to question number 3 here. So we want to find the area between z-score of 0.45 and 1.45, right? So always, 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 with all of these, draw your distribution. And remember that right down the center is a mean of 0 because these are z-scores that we're talking about. Next thing we want to do is we want to find out our area that we're looking for. So it's just approximately, you know, if that is 0 there, that could be 0.45 is what I'm looking for, not 43. So 0.45 here. And again, when you're drawing this, it's approximate. You don't need to figure it out exactly. And then over here, let's call that z-score, the other one that we're interested in, which is the 1.45. Okay, so this is the area that we're interested in right here. However, you are not going to find that area anywhere on the in your table. So what you need to do for these types of questions is you need to realize that we're dealing with 2 ranges here. One range that we're dealing with is the area between, in this case, and it takes a little bit, you're gonna vary this depending upon the situation, but we have the mean between a z-score of 0 and, the mean and a z-score of 1.45, right? So that is one of our areas. And this area between a z-score of 1.45 and the mean, you can look that one up, right? That's in your table, so we color that in. We definitely know that one is there. The other area that we can look up is the area of 0.45 between a z-score of 0.45 and the mean. That is also in your table, right? So that's also in that table. So now the last thing that we need to do is we need to realize that the area between 0.45 and 1.45 is basically this little part here. It's basically the area that you would get if you took this percentage of the curve and took away that part of the curve, right? So this part is too big, but if we take away this part, what's left over is that portion between 0.45 and 1.45. What's left over is exactly the area that we're looking for. So this one is just a combination of 2 moves where you look up the area between the mean and 0.45. You look up the area between the mean and 1.45, which we've done. That's pretty standard. And then the last thing we need to realize is that we need to take away that area of 0.45 from the area of 1.45, and what's left over is the percentage of the distribution between those 2 areas. All right, so this is the way that this one shook out. It's not always going to be that. You might have to use different sections. It might have to be, you know, the area below a z-score minus, you know, another area below a z-score. Whatever it is to figure it out, though, you can find the portions of it in your unit normal distribution table, and then you can find, if you draw it out, it'll become apparent which area do you have to subtract from which other area. All right, so there was a request to do another one of these. So I'm gonna do a different one, and this will illustrate just the kind of different situations and things that you might be finding yourself in ways that you need to do these. So we're going to do C, which is between 0.32, z-score of 0.32 minus, 0.32 and 1.26. So always, always, always on the draw out your curve. Your curve, you're going to be dealing with a lot of pieces. You're going to be dealing with negative z-scores, positive z-scores, below the mean, below the z-score, from the mean to the z-score. There's a lot of places where things can go wrong. The more you try to do in your head, the more chances you have to just overload your working memory. So, you know, literally a few seconds, draw it out. It doesn't even have to look good. This one looks horrible, but it's going to work. So we have our mean of 0. And this time we want to know what is between a z-score of minus 0.32 and what is between a z-score of positive 1.26. So for this one, it's actually a little bit more straightforward, because this one, the two pieces that we need, we can almost directly look up. So if we want this entire area, the area that is between 0.32 and 1.26, if we shade in this part here, we can see that part of that area is the percentage between the mean and minus 0.32. We can look this up directly in the table, right? We just have to remember that we need to flip it because we don't have minus z-scores in the table, they're all positive. But we need this piece of that area. And then we also need this piece of the area. And once again, from the mean to a z-score of 1.26, we can find that piece that's actually straight in the table as well. So the final thing we need to do is just combine the two. We want both of those areas. So in this case, just because of the areas that we're being asked for, instead of subtracting any of this, we're going to add the two. We're going to add this area to this area, and then the total area that we get is going to be the area between those two. So in these questions, again, draw it out, and then try to think about what pieces do you need that you have in your table. How can you possibly make the area that you're looking for pieces of 0 to the mean, pieces of above, you know, that z-score, and then use that to figure it out, look up the correct numbers, and then sometimes you're going to have to subtract those numbers, like in question A. Sometimes you're going to have to add those numbers, like in question C. It all sort of depends upon the areas that you're looking for. All right, so I think we had, this was a good practice time. We are not going to introduce samples and populations this time. We're going to save it for next time. But we got about 3 minutes left. So if there's any more questions, call me over. But again, make sure that you are keeping up with the due dates. Some of them were moved. Make sure you're checking the MyLab. They were pushed back, but make sure again that you're staying on top of that. Go over to your exam. Do not let it be unknown to you why you might not have gotten 100 on your exam. If you did not, make sure that you know exactly what you did. And keep practicing these. We are going to be going to the unit normal table a lot. And once we're done going to the unit normal table, we are going to go to other tables that are like the unit normal table. So we're going to be using table-like things for a while. So get yourself very familiar with it. Develop those strategies for using that table, because this is going to be one of the fundamental skills that we're going to use as we push forward and do inferential statistics. So we still got 2 minutes of practice time for anybody that wants to stick around, but that's all that I wanted to cover today. So let me know and I'll come over and help. Otherwise, have yourself a great day.